Good afternoon, everyone. My name is Savannah DaCosta, and I'm your data science lead at Big Think. And today we'll be going over week one's data frame manipulation using pandas. Now, this is a bit of an introduction to pandas and a bit of an introduction to data manipulation with the pandas data structures. And so Pandas is basically a Python library that allows for a wide variety of data analysis and manipulation techniques. While you could do this by building lists in Python, similar to an Excel sheet, it would be really cumbersome to work with. And then it would be also pretty cumbersome to actually build out too. And so Pandas just allows us to use default data structures, like a table-like data structure, which are data frames, for the easy manipulation of the data in a row and column fashion. It's very intuitive to deal with. And what's really great about Pandas is that it comes with a whole suite of different functions that are associated with the library, and so that adds to the practicality of using Pandas. And so for our first task, we just need to import. We're going to need to import our file that we're going to use for data manipulation. So it's just going to be like a CSV file. And let's actually double check if we have the file in here. If we don't, then you're just going to get an extra bit of seeing how to upload files. Let's double check if we have that file in here. Okay, so we probably don't. So let's just do it quickly anyway. And so we're going to import watches in here. And let's see, we're going to move this into this folder. Or let's just see if we can just directly import it here into this folder. Okay, awesome. Now we got it in there. So we can close this out now. And maybe a few little, little notes you want to take. Well, not really notes, but little things to add. It's just like if you want to remove all the cell outputs afterwards, you're going to want to go over here to edit, and then you go clear all outputs after you're done running a cell, or if you're done using the whole notebook and you just want to reset everything so you can sort of just practice again. Anyways, going on, now that we have our file within our work environment, we can just run the function, and it's going to actually pick up the file. So we run the import function. Well, we run import using we're going to import pandas and give it an alias, and then using that alias, we can actually access pandas functions. So we're going to access read CSV, which is the general way that we import files, CSV files in particular, of course. So now you see this check mark. It means that it's ran and it's ready to go. And so what the data frame allows us to do is that it allows us to actually filter data more efficiently than using just pure Python. And it does that in two distinct ways. In particular, one, you use less code because you're using the pandas library, which has functions associated with it. So you don't have to build out your own functions. So that makes it really easy. And two, it just runs more efficiently than pure Python. And it's able to do this using two fundamental data structures, actually. So it uses series and data frames. So what are series, right? So series, you can kind of just think of as a single column with an index associated. And what it really, you can also think of similarly, you can think of a data frame as actually a collection of different series. So one column in the data frame is its own particular series, actually. So yeah, that's pretty much how you can basically think of the data frame and series pair, that just an individual column in a data frame is a series. And it's just that the series will be associated with its own index as well if you wanted to just extract that particular column. Now, going forward, we wanted to be able to preview our data. This is just some of the basics when it comes to just some data analysis or even just viewing data in general. So we use .head and .tail. These are also part of the pandas library and pertain to data frames. And so its default, actually, when you run .head, is that it's going to give you the first 5 lines or the first 5 rows of your data frame. So we do here .head, 0 through 4, first 5. But you can also do any other arbitrary number that's a little positive number, of course. So you can do 10 if you wanted to. And you can get the first 10 going 0 through 9. Similarly, with tail, it gives you the first 5. The last 5 of your data frame. So you can see that your data frame basically has 75 different rows going from 0 to 74. And you could also just see the last 10. There you go. And what's really awesome is that you can also just access a particular column and get that output of just the column by doing what's essentially referred to as slicing. And slicing is just like when you get your data frame and you bracket it and you like indicate that you want one particular column using brackets. So over here, I just want price. I can do the same thing for engagement, condition, store, model, and etc. If you had more columns, you are not able to do that for indices. Of course, indices are just a default part of a data frame or series. They're just there to enumerate things, so you can't really access them. So over here, we can access price. You can see it prints out price. Now, as previously mentioned, a slice of a data frame is actually its own series. So we're going to actually check the data type of this object that we have here in particular to validate that it is indeed a series. Now, this is actually important to note because there are some functions that do not work on series and they can only work on data frames and vice versa. All right. Now, going forward, we're going to get into some logical filtering of your data frames, and we're going to be doing this logical filtering using the functions .lock and .ilock. These are, of course, part of the pandas library. And so over here, you see three logical conditions over here. And what .lock allows you to do is basically allows you to filter using the column names, essentially. The column names and the values that are under that column, or filter based on the values that are under that column. So every column name can also be thought of as an attribute of a data frame. So as or a property, attribute or property. So engagement is a property of this data frame because engagement is a column of this data frame. And similarly, condition and price. These are all things that you can access as attributes. So actually, let's try to see if we can insert another cell here. Code cell. Let's see. Let's just see if we can just do this separately, just to see what this gives us. Engagement. See, so it automatically can fill in what you wanted because it knows that this is a property of the current data frame that you're using, that you have this engagement. And over here, you'll see that it outputs another series. This is essentially just a series. So this is just another way to access the series. And instead of slicing, you could do this if you prefer that automatic what you call input or whatever that allows you to do, intelligent input or whatever. But it doesn't allow you to do as many sort of slice manipulations, because you could, let's say, if you wanted to just even reduce the size of this data frame and just wanted to get, let's just say you just wanted these numerical values, you could just slice the data frame in a way that it gives you just engagement, price, store, model, or just engagement and price. If you didn't want this condition over here or any sort of slice that you want, you could slice the data frame that just gives you model and store, so on and so on. So you wouldn't be using .engagement in particular. So yeah, let's continue on. Sorry about that tangent, but let's continue on with the logical indexing and the logical filtering. So over here, these are the features of the data frame. And so we want to basically filter the engagement column so that we're only getting basically views of stores. I'm sorry, it would have been best if I actually explained to you how this data set looks like. So you have your model, your store, your condition, your engagement. And your engagement metric in particular is actually how many people are actually viewing, let's say, your online store. This is just or it's some metric that basically tells you how much attention a store is getting. And that can also be the particular model of watch as well. So this this particular watch at this particular store with this particular condition is getting this many engagements. So it's not so hard to think about. So you can just go through the different attributes and say, okay, well, this particular watch model at this store and it's new and it's getting this many engagements. So there's a lot of people who are interested. And so, yeah, let's continue. So we want our engagement value to be over 77. We want our condition of the condition of our watch to just be fair. We only want fair condition watches that have an engagement value greater than 77 and to have a price lower than 550. And let's see how many of those that we get. We run this cell and we get 1. So we could also just even reduce this. So like, let's say we don't really care about the price. We just want to see all of them that have fair condition and an engagement metric of above 77. We can just remove this logical condition. And we get a lot more. We get about 1, 2, 3, 4, 5, 6, 7, 8, 9 different watches, but they're all pretty pricey. So I think I'm going to stick to the first watch over there. So going forward, we can do a similar sort of logical indexing. Well, it's not logical indexing. It's actually specifically just numerical indexing using ilog, and the I standing for index. And basically, you can just throw in 2 values of like where you want to start and where you want it to end. Now, do remember actually that like where you want it to end is actually 1 minus. So let's say if I'm saying 16 to 50, yeah, it's going to start at 16, like row 16, but it's actually going to end at 49. So let's just run this and see it. So you start at 16, ends at 49. So just keep a note of that, so you don't get confused with like why isn't this function working, or like, you know, go into some, you know, side thought of like, okay, what's going on with my code? It's like, well, it's nothing wrong with your code. It's just the way that like this particular function works. So if you wanted to get like actually 50, you do 51. So you start, so you can see here it starts at 16, goes down to 50. And that's just probably like a cause of Python starting at 0 as like its default starting point index. Now, here's the thing that we can also do with our data frames. So pandas assigns a serial number of indices, or serial number indices, by default to our data frames, and you can see them in bold over here. So they're right there. And if you wanted to set you can also just set your own custom indices if you wanted to, if that's more convenient for you. Let's say if numbers don't really do anything for you in terms of looking at your data, then you could actually just set some of those columns that you have, those column names, to indices as well. And what's important to note is that like once you send them to indices, they can no longer be accessed as columns. Actually, they essentially can't be accessed at all. So let's do this. So now you can notice that they've been subscripted as opposed to the engagement metric and price that are superscripted, left superscripted. So you could see up here when they were all at the same sort of like level, but now that change in level, the subscript and the superscript indicates to you that okay, these are now indices, and these are still columns, accessible columns. Now to show you that they can't be accessed, I'll just like add another cell, and let's try to say I want to get a slice of model, and this should return an error because this is no longer an accessible column to get any sort of slice of or to do any sort of operations on, any sort of functions on. So see, you get key error. So okay, model, key error, model. The above exception was the direct cause of the following exception. You get this particular key error. So it's just saying that the model is not a key or an attribute within this data frame, which it isn't now. It's an index. It's just there basically just for show. So we can remove this. Now we're going to get into grouping some data using the .group by function. Now, grouping your data by a subset of variables in the data frame is a common task that Pandas is really good at. And we can use the group by method to do this. You can think of a group by as a for loop that goes through the values of some user-specified columns, and in each iteration extracts only those data frame rows that match the value in the specified column. And the group by is most useful when you use it together with an aggregation function. And an aggregation function is just something that's going to summarize your data, like a sum, a mean, and so on. And here we're going to group our data by the model and condition. And then the resulting object has all of the data from the data frame partitioned into pieces depending on the values of the two variables we are grouping by. And so, yeah, now we're just going to start and see what we get. What's important to note is that a group by, when you do a group by, so over here you basically have the summation by mean, so the average value of fair watches of this model in a good condition, in a fair condition, and a like new condition, new, and very good. So this is just going to be the average prices. So that's regardless of store. This is just like in totality, this is what you get. Regardless of store and regardless of engagement metrics, this is just the average price. Since these are the only things that you've considered, model and condition. Now you could add more or even just go down to less, like you just want to go by model and not even care about the condition. So you'd probably have less rows in that case. So let's just see if we can try that out right now. Yeah, let's just remove model and run this. But you see even less rows because now it's just going by condition. This is the average price of watches by just their conditions. And similarly over here, you could do a group by, but just model. This would be the average price by model. And yeah, what's important to note is that like you see that like we were able to perform like what we get out here is basically like looks like a series. Hold on. Well, it's not really like a series in particular. It's actually what you get from using group by as a group by object. And with group by objects, you can't actually use data frame related functions on them. It's a separate, since it's a separate kind of object, you have to use group by related functions or convert it back into a data frame. But we won't be really covering converting into a data frame over here. So we want to just verify what type of object this is that we're dealing with. In fact, it is indeed a data frame group by object. So these are important to note. It's important to check the type of your data structure so that you know which subset of functions that you can use on it. And some subsets of these functions may be functions that can actually transform it into whatever other data structure that you want. So like I mentioned before, a group by function into a data frame could actually be very advantageous. Now we're going to go over pivoting a bit, and y'all can read this by yourself. But so pivoting is basically a way for us to like reshape our data frame. Pivotally, like sort of the same as grouping plus some sort of aggregation function. The difference is that you have some of the grouping variables as columns instead of rows, and that can make it nicer to look at. And maybe it can help you like summarize your data in a more visually appealing way, or a way that like better fits the format of like some sort of paper that you want to put it on or whatever. And so we use dot pivot table. And this is basically the format of what you're going to put in. You're going to put in your data frame. You're going to put in your numerical column that you want to, that's basically going to populate all of the non-label cells of this new data frame that you're going to be creating. And then you have your indexes, so your row variable and your column variable, which are going to be like your labels for every column and row. And let's see what we get. So over here, yeah, oops, low battery. Hold on. We need to charge. Yeah, excuse the little hiccups here. First video. But yes. So you see that we have this this pd.pivot. pd underscore pivot is the name of our object here. And let's just check what type this object is. It is indeed a data frame, and that's awesome. And you can see over here, it's basically the model is going to be your index. So, well, the index for the rows over here. Oh yeah, index. And so these are all the model types. And then your columns are its conditions. So over here, fair, good, like new, very good. And this over here, your price is basically, well, this basically just tells you what numerical value is being represented in your data frame here. So this is basically just all just price values. It's a data frame of all price values. It's not going to be like, price plus engagement and all that sort of stuff. All right. And that's just important to know that like you will just have unless you could, I think, let's just double check. Let's see if we can actually add engagement here as well. Actually, our data frame changed. So let's just make sure. So engagement is still a property. Yes. So we did price once. Let's just see if we can add engagement. Am I forgetting how to spell? Twitter. Oh my gosh, totally forgot how to spell. All right, let's run this and see what we get. Okay, that's nice. So we can see that, yeah, we can also just add other or more numerical values to assess, and it'll basically just be split down the middle, or it'll be partitioned based on how many numerical values you've added. So we have engagement here, and we have price here. So these are, let's see, very good. There you go. So we have fair, good, like, new, new. Then we have very good. This is still engagement values up until here. Then we have our price. Then we go fair, good, like, new, new, and then very good. Similar, just a similar order, basically, of the type of condition, which is nice to see. That's just consistent. And yeah, we already checked the data frame, and so we're solid. Now let's see. Now we're going to unstack our data frame. Now, what is unstacking? So sometimes we want to reduce the number of rows without removing any data points, like when we need to paste our table into a report or want to fit into some single page. Additionally, having conditions as a single column makes it difficult to locate the value that corresponds to each possible condition, like, the aforementioned conditions of like new, etc. And we can address both of these issues using something called unstacking. And when you unstack a data frame, you take its innermost index level. So let's just check back what's our innermost index level so we can see an expected output. Our innermost index level is condition. So we're going to take our innermost index level, in this case condition, and turn it into a column of its own. And then the data frame gets rearranged accordingly. This has the consequence of reducing the number of rows in your data set while increasing the number of columns. In other words, when you unstack, you reshape your data frame from long to wide format. And so we're going to run this really quick. And so this is now our wide format. And let's see, it was condition. Yes, a condition that was basically taken to create more column values. And condition was our innermost index. And we're going to save this actually into its own little variable. We're going to call it my unstack df. And we're going to run it again and just see the head, because we don't need to see the whole thing. We already saw the whole thing. And what we're going to do is we're going to actually put it back together the way it was before. We're going to stack it back. This basically just undoes your stacking. And I'm going to show you the whole output. Whole output is the original data frame, but it's actually grouped. It's actually grouped more, let's say, not cohesively, but like if you actually go back and check the original data frame, you'll see that like the condition in particular, the innermost index, is sparsely spread. So what I mean by that is like, okay, let's first, let's see if we can. Okay, we can only see this much, but anyways, we look at, let's say, this model, and we actually find its corresponding conditions are new, like, new, and good. There's actually more conditions than that. In total, there are like, I believe, 5 conditions. There's new, like, new, good, fair, very good. Yeah, I believe it's 5. Yeah, it's about 5. Yeah, it is 5. But yeah, so you can see that, like, yeah, it's missing some conditions. Well, that's just because it's actually like distributed a little bit more sparsely in the original data frame. So like you'd find another, you know, and it's actually the similar thing with store as well. It's like these are distributed sparsely, so like they're not all aggregated to the model. To the model of the watch, that like, okay, now they have this model of watch, and here are all these stores that have these watches, and here are all the conditions of the stores that have these watches. But when you actually stack it, you get a more aggregated form. So over here, you get model, then you have your particular store, and then you have all the conditions for that particular store, given that specific model. Well, all the conditions for the model given that store. I guess that actually would make more sense. So we could actually rearrange. Well, we'd have to get the original data frame to rearrange the indices in a way that makes more sense to us. So let's say maybe it would make more sense to like have store first, and then model, and then condition. I think I would actually prefer that as well. And so yeah, we actually just this is the unstacked. Well, yeah, this is unstacked. The unstacked data frame, which was this. Now we stacked it using the dot stack. And yeah, And that's pretty much the end of our little lesson here. I hope you guys enjoyed it. Hope it was informative. The actual data and notebook have been posted in the group me. You can find it, I believe, in the general. If you scroll up and check back on some of the older messages, you can find it. Or you could just contact me through group me, Bird of Hermes, and ask any sort of questions, and just play around with this notebook and make sure you understand it, make sure you understand these functions, and yeah, hope you enjoyed.